When it comes to selecting an electronics package for your car, there's a lot to consider. First of all, there's the ECU, then potentially a power distribution module, then maybe a wideband controller, and even a data logger. We're here at PRI with Andy from Haltech Engine Management to talk about Haltech's Swiss Army knife of the engine management business, the Nexus R5. So this Nexus R5, you're only previewing it here at the PRI show. It's not available just yet for public consumption, but tell us what it is.
It's basically an all-in-one box. So ECU, PDM, dual widebands, Datalogger.
Now, I think in the past, Haltech has maybe been blamed for requiring multiple boxes to basically run a more advanced car with external wideband controllers, maybe a race engine expansion module, I should say. And have you kind of gone the opposite way there, bringing everything on board? What is the problem here that you were trying to solve with the Nexus R5?
Yeah, well, essentially it's that the fact that you do have so many boxes and you need so many interconnections between them. And also, every time you have an interconnection, you've got to wire it up, you've got to mount the other box. You have to then configure whatever you need to configure in both boxes, so you need multiple packages of software to do it. So this way, having it all in one makes it a lot easier for people to set up.
All right, so what I think we should probably do is just break down these individual components and talk about them separately as if they are an individual box. So let's start with the ECU. Haltech, obviously no stranger to engine management. We've been running the Haltech Elite 2500 in one of our development cars for some time. So what are the changes from the existing Elite platform that we'll see in the Nexus R5?
Yeah, okay. Well, to the user, it just looks like a big ECU, basically. There's 18 injector outputs, 12 ignition outputs, 8 DPO, 4 drive-by-wire pins, as in you can do...
So two drive-by-wire?
Yeah, so 2 throttles. So from that sense, it's fairly much the same as the Elite. Internally, it's quite different. It's based on the Elite firmware, so it still has all the same functions that you're used to on the Elite, and if you've got an Elite map, you can load it into this. But internally, it is quite different, so we've got a lot of extra help in the background to make things like communications a lot faster and data logging a lot faster and that sort of thing.
Ultimately, the Elite has been around for a few years, and I'm guessing the electronics technology moves on, so this is just taking in the next generation of electronics components as well?
Yeah, in some respects that's true. In other respects, there are parts of the circuit which are quite physically large because they have to do a lot, and with new components available and more say market validation, we've been able to reduce those, which is good because otherwise the ECU would be this size. So yeah, it's an ongoing development, basically.
Now you mentioned 18 injector outputs, and obviously as cars or engines have been making more and more power, we're seeing the requirements for more fuel. Stage injection, particularly 2 stages, is pretty common, so obviously you've got the ability there to support 2 stages of injection on a V8, but can we also incorporate multiple stages on a 6-cylinder, maybe 3 stages there?
Yeah, so the Elite firmware already supports up to 4 stages of injection, so you could do 3 stages on a 6-cylinder if you wanted, or I'm not going to try and do the math to work out how many you could do with 4 stages. The Elite also supports the different numbers of injectors per stage. So you can do, say, on an 8-cylinder injection engine, you could have 8 port injectors and then 4 injectors above the supercharger, that sort of thing. So you can mix and match. Or
methanol injection as well, if you wanted to add that?
Yeah, that's the idea. So I think one of the possible configurations was to have a 2-stage 8-cylinder and then a separate methanol injector before each turbocharger compressor.
Hence that additional 2 injectors. You've got the 16 for the port injectors plus 2 for the methanol.
Yeah, or 3 stages of a 6-cylinder, as you mentioned.
Okay, so in terms of the other inputs or outputs there, you did use the term DPO. So for those who aren't coming from a Haltech sort of background, what's that mean?
So that's just a low side drive auxiliary output.
So an auxiliary output to switch on something like a fuel pump, a fan, etc.?
Yeah, well, normally they don't have enough current to drive a fuel pump or a fan directly, so normally they'll go through a relay, but you would normally use a DPO to drive a boost control solenoid or something like that.
Now that sort of brings me to the next point. So obviously, as you just mentioned there, the DPO, if you're switching something that's low current, you can pulse width modulate it as well, like the boost control solenoid. But as you mentioned there, you normally with an ECU can't directly switch those higher current draw. Maybe you've got a fuel pump that's going to draw 10 to 14 amps and potentially something similar with a fan. So let's move on there to the PDM side of things. So power distribution module. These are becoming more and more common. I think a lot of our followers probably already have a bit of an idea, but in a nutshell, can you break down how they work?
Yeah, so basically it's a way to replace your fuse and relay box with some that's solid state. Initially, I didn't really get it. I was thinking, why would you want to do this? Because you can't just replace, say, a fuse or relay or something like that. But the benefits are, first of all, that, well, you don't need to because they're actually more robust than electromechanical relays. Secondly, you can program in much better current protection strategies than you can with a simple fuse. Thirdly, it gives you a lot of good diagnostics, so you can see how much current each channel is drawing, and you can monitor the voltage of each output and that sort of thing. Whereas if you have a relay box, if you want to find out why your thermofan's not getting power, for example, you can check the fuse. Okay, fuse is okay. Check the relay. Okay, relay's okay, and you have to basically trace through the circuit. So having a solid state way enables you to do a lot better diagnostics.
Now, I think the other part that's often overlooked, even with a conventional power distribution module that's external to the ECU, is that it does simplify massively the wiring, and I think this is really easy to overlook. Particularly if you're paying a professional auto electrician to wire up a car, there's a huge amount of time that goes into wiring up and mounting the individual relays, and then of course the switches to control those relays. Yeah. So the power distribution module gets rid of that. Yes, you'll be paying a premium for the power distribution module, but actually when you take the labor into account, often they're not substantially more money, and then you've got that additional control. So just talking about the control we've got over the electronic fusing, if you like. So we can set a particular output. Say we're talking about a fuel pump. So you can set the current at which the circuit will trip or break down, but then you can also reset that as well. Can you tell us how that works?
Yeah, so at the moment the way it works is you've got a peak current where if it exceeds that, it will just switch the output off. Well, go into the retry state, which I'll explain afterwards. Or you can have a sustained current. So if it's more than this current for more than a second or 2 seconds or whatever you want to specify, then it'll trip. And then you've got a maximum number of retries before it will actually switch that output off until you do a power cycle.
So in terms of a conventional system, if your fuel pump current becomes too great, it'll trip the fuse, blow that fuse, and you've got no fuel pump. The only way of getting around that is to physically remove that fuse and replace it. So this retry, this is an electronic process. Basically when it exceeds that fusing current, it'll wait. Can you specify a period of time it'll wait before it retries?
At the moment that's fixed, but depending on the feedback that we get from the market, we can make that variable if needed.
So basically it can retry that circuit. Maybe your fuel pump's just right on the edge, and it could be enough just to be able to get your car back to the pits, for example, to actually effect a proper repair.
Yeah, that sort of thing.
And then on top of that, as you say, you've got the ability to monitor the current draw, the voltages on each of those pins, so you can actually see exactly what's going on in real time.
Yeah, and that also enables you to set what your current threshold should be. Because otherwise,
as opposed to guessing.
Exactly, yeah. I don't know, 30 amps seems like good for a fuel pump.
Yeah.
Who knows?
Now, the other aspect here, with a lot of the outputs, we may not want to drive them completely on. Let's say a fan, we might want to, at sort of, as the engine's coming up to operating temperature, we might want to drive it at maybe 30 or 50% of its capability. Can you do that using the built-in PDM?
Yes, yeah, you can. So you can pulse width modulate the outputs on the PDM. So I actually do that on my daily driver. So I run my thermofan as a variable duty cycle against coolant temperature, so it just sits at wherever it's happy, and it's nice. It's cool.
Now, when Haltech announced this just 24 hours ago before we arrived here at PRI, we had a few questions on our Facebook page about this product, and one of them was around the heat handling capability with that PDM, particularly when you're pulse width modulating an output. This generates, as far as I understand, heat on the board. You've got the ECU sitting right there. So heat control and also noise suppression, are these real issues, and how are you dealing with those?
Well, there's certainly technical risks, and they're ones that we identified very early and did a lot of testing on. So the engineer that designed a lot of this for us, his background's in power distribution. So he designs things like for substation transformers to last for 60 years and that sort of thing. So he's very conservative with his design, which is good. So we're calling them 25 amp outputs. Actually, they can handle a lot more than that. That's just what he's happy to put on them. And yeah, we've tested them at I don't think marketing's allowing me to say how fast yet, but very high frequencies on the PDM outputs for things like fuel pumps and thermofans, because they're the ones that you need to pulse width modulate at high speeds.
So ultimately, you're confident that when this thing hits the market, it is going to be robust and reliable?
Yeah, we've done a lot of thermal testing on it with flare guns and that sort of thing, and loading up all the outputs at once, which if you calculate 4 times 25 plus 12 times 8, it's about 200 amps.
Yeah, that's a lot of current. I'm glad you just mentioned that. My next question was going to be how many outputs do you have on that PDM and what are their currents? So you've managed to handle that nicely. Now the third component there is of course the wideband controller. Not a lot of rocket science going on there. The wideband controller market's pretty well established. Haltech already have their own external wideband controller. So why have you decided to bring that on board?
Well, I'd say it's not all that well established for NTK sensors yet.
So the existing one was an LSU 4.9 controller.
Yeah.
And where's the advantage with the NTK sensor controller, or the NTK sensor, I should say?
From what I've been told by people that run a lot of methanol cars, the NTK sensors are more robust in that environment than the 4.9s. My experience with them is that they seem to need more current to control them. They seem to be more robust in my very limited testing, and they can certainly read richer mixtures than the 4.9s. That's my very uninformed.
Well, that matches my own experience with methanol jet cars. They definitely read to a lower lambda number, and I tend to see that they are more reliable, so I think that makes sense for those running street cars, because the NTK sensor is more expensive than the 4.9. Is it compatible with both? Can you just select the sensor you're running?
Yeah, so you can just select whether it's the 4.9 or the NTK. At the moment, we only support the calibration resistor that comes with the sensor. In the future, we may support free air calibration on them, but if the calibration resistor is there, then that makes it easy for people. So we're trying to make life easy for people. Yeah,
I think in the past, most of the wideband controllers supported free air calibration. That's sort of the way we went about it. But again, those calibration resistors are there for a reason, and if you can just plug it in and not have to worry about it, I think that makes a lot of sense. Now, another aspect you've included on this ECU is Wi-Fi compatibility. Now, I just want to talk a little bit about the way you can communicate with it. It's got USB-C on it, it's got Wi-Fi, and I want to talk about the elephant in the room with the Elite ESP software. A real bugbear for a lot of tuners was the connection time. Yeah. I've timed it myself on my own laptop with a 2500 at around about 40 to 45 seconds. It might not sound like a lot, but that's an eternity, particularly if a car comes into the pits and you want to make a small change. How long does it take to get live with this ECU?
It's about 5 seconds.
Okay, I think that's a substantial improvement. So just with the ability to use the USB-C or Wi-Fi, is it just a case of whether you want to be in the car connected with USB-C, or from outside of the car you can use the Wi-Fi, and if so, what's the sort of range on the Wi-Fi?
Well, so far in our office we've tested over 10, 15 metres sort of thing. I think we've had cars actually downstairs in our workshop, and we've been talking to them upstairs from our PCs. But it's going to depend on how noisy the environment is and how thick walls you've got in between them and that sort of thing. It's a normal Wi-Fi sort of problem.
How are you handling security so someone else doesn't get live with your ECU?
Yeah, so at the moment there are two ways of doing that. One of them is through the USB you can actually lock out the Wi-Fi completely. And then at the moment the ECU only supports being an access point, so you join it from your laptop. And to join that you have to use the normal WPA authentication. So in the future, we may allow the ECU to join another network so that you can use a router and that sort of thing. That's got additional security issues, so we're not exactly sure what we're going to do with respect to that yet. But at the moment, if you want to be the most secure, you can just disable the Wi-Fi, and otherwise you just connect to it with a laptop with a normal WPA security.
Now, this ECU also has built-in data logging. I just want to talk a little bit about that, and also because you're going to be downloading the data via one of those two connection points as well, the speed of that. So how big is the data logging memory?
512 megabytes.
Okay, now how many channels can we log into it, and what sort of logging rates or frequencies can we log at?
My original spec was 100 channels at 1 kilohertz. So we've tested at 300 channels at 500 hertz, and I think we've done it at 150 channels at 1 kilohertz as well. So when I was testing it at 100 channels at 1K, it was about half the bandwidth of the chip. So there's still a bit of room there, but it's going to depend on how fast any of those channels actually update.
I mean, I think it's fair to say like 1 kilohertz, that's amazing, but it's a very, very fast logging rate and probably well in excess of what most would need, unless you're looking at some very fast moving inputs. So not strictly something that you'd be using 100 channels as. Is that fair?
Yeah, I'd say so. Because I'm a bit of a nerd, I like to see the hair on the dog's back, you know. So I like seeing all the data there, and can always use more data, but yeah, you're right. It's not really necessary for most cases.
To put some rough numbers in, I mean, it's really going to depend on the channels you're logging, obviously the logging rates, but for me, most of the channels that I'm usually looking at, maybe engine speed, manifold pressure, throttle position, those sort of channels, I'd probably be logging somewhere more in the region of about 20 to maybe 50 hertz, definitely not around 1 kilohertz. So if we're logging maybe 100 channels around those sort of 25 hertz, what sort of log time are we likely to see? Just really roughly. I don't need you to get out your calculator here.
Okay.
The internet can correct you.
Yeah, okay. Well, if it's 100 channels at 25 hertz, each channel's 4 bytes. So that's 10K per second, which is 600K per minute. Is that right? 600K per minute. So that's almost 1,000 minutes to get to 512 megabytes then.
That should count for just about anyone other than endurance races, right?
Well, 1,000 minutes is... Okay, you couldn't quite do the Bathurst 12-hour in that, but yeah. But for that, you wouldn't want to be... you want to get the data out some other way, I'd expect.
There's definitely an impressive jump up from what we've seen on the existing product. Now, as I sort of mentioned as well, getting that data out. So there's a variety of different ways of communicating with ECUs. Obviously, you've got the USB-C and the Wi-Fi connection. A lot of ECUs use Ethernet. I know I've seen that's quite common as well. What's the advantages with the USB-C and your Wi-Fi? How quickly can you get that data out?
Well, the reason why we kept with USB 2 is because it's faster than Ethernet, unless you go to gigabit Ethernet. So normal 100 meg Ethernet is 100 megabits a second. USB 2 is 480. With the we're still optimizing this, but so far it looks like we'll be able to get the data out of the Datalogging memory at about 20 megabytes per second.
So that's megabytes, not megabits. Yes. It's a very big difference.
Yes, megabytes per second. And that's actually one of the major hardware design differences between this and the Elite, is because when they decided that we needed to have 512 megabytes of data logging memory, I said, well, hang on a second, we need to get it out a lot faster than we're getting out our data at the moment, because if that's so that people can record more data, they need to be able to get it out. They'll expect to get it out in the same speed, so in the same time, I mean. So with Wi-Fi, it's a lot slower than that. But we haven't really optimized that yet either, so I can't really give you times on Wi-Fi.
Again, it's important to mention to our viewers here that this is a pre-release of the product, and we're still a good few months away from it being out for public consumption, so understandable there. A couple of things maybe a little bit out of order here, but just come to me as well. Have you included an oscilloscope function here? It's very handy often for diagnosing problems with your trigger inputs from the engine.
Trigger inputs? You're thinking too small, Andre. Yeah, so there's a built-in oscilloscope which has got 4 channels on it, and you can look at any channel in the ECU. So that includes your trigger and home voltages and that sort of thing, but also all the calculated channels as well. So you can see the current engine angle, which if your triggering is working correctly, it should just look like a sawtooth. I just did a test on it, looking at a throttle stab off idle on my daily, so you can see in very short time domains how quickly the throttle body moves and that sort of thing, and you can see the little bumps in the map signal as each cylinder does its intake stroke, and also the RPM wiggles because it's a 60-2 trigger, so you can see, as each cylinder does its power stroke as well, and how they get smaller in amplitude as the RPM increases, and yeah.
So a lot of powerful stuff there for really analysing exactly what's going on any of those inputs. Now, it's worth mentioning here, because I know we're going to have a lot of people asking, what's it going to be worth? So we need to address that as well. You haven't got a price point set for it yet. When is it going to be available, and when is pricing information likely to be announced?
I'm in R&D, so I just make the box, so I don't know. No, it's going to be available in March. In terms of the pricing, it'll be, as far as I know, it'll be Right, as in it'll be set for what you'd need to do to, if you had all these boxes separately, it'll be...
It's safe to assume it's not an entry-level product. We've got a lot of functionality in there, and it's obviously spec'd to suit those with more complex engines, given that you've got 18 injector output. So obviously the price is going to reflect that.
Yeah, definitely.
All right, look, Andy, it's a really innovative product. It's certainly the first time I've seen all of those components put into one box. Really interested to see how it all pans out once we actually get a chance to play with one. Thanks for your time there.
My pleasure. Thanks, Andre.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.